Let's talk about that moment of frustration. You know, when your favorite app just stops, grinds to a halt right when you need it most. Ever wonder why that happens? Well, today we're diving deep into that very problem. We're going to unravel the super delicate balancing act between speed, handling tons of users, and just plain old stability.
In this quote, it nails it. Building an app that works for you and a few friends, that's one thing. But building something that can handle millions of people all at once, that is a whole different universe. Because at that kind of scale, tiny little performance hiccups don't just get bigger, they explode.
So that's the million-dollar question, right? How do you actually do it? And spoiler alert, it's not just about throwing more money and more servers at the problem. Nope, it's about smart design. It's about understanding the trade-offs. And it's about mastering the key principles we're about to get into right now.
Okay, so at its core, the problem is basically a giant tug of war. On one side, you have users who expect things to be blazing fast, instant. On the other side, you have the system trying to handle thousands, maybe millions of those users, all at the same time. These two demands are just constantly pulling against each other.
And here's where we hit our first huge wall. We all expect instant gratification online. You tap a button, you want a result. Now. But the databases holding all that precious information, they are, by their very nature, kind of slow. They're almost always the biggest bottleneck. And in a world where a tenth of a second delay can literally cost a big company millions in sales, that bottleneck is a massive, massive problem.
All right, so how do we get around that bottleneck? How do we solve for speed? Well, we bring in our first big solution, caching. You can think of this as the nitro boost for our application. It's our #1 weapon against slowness.
So what exactly is a cache? The easiest way to think about it is like your brain's short-term memory. You know, instead of running to the library, which is our slow database, every single time you need to remember a fact, you keep the really common stuff right at the front of your mind, ready to go. That's a cache. It's a small, super fast memory layer for frequently used info. And the difference here is it's just staggering. We're not talking about a small improvement. We're talking about going from milliseconds to microseconds. That is 1,000 times faster. It's the difference between an app that feels clunky and one that feels instantaneous.
And here's how it works. It's actually pretty clever. When a request for data comes in, the app doesn't go to the database first. It checks the super fast cache. If the data is there, we call that a cache hit. Boom, it's returned instantly. If it's not there, a cache miss. Okay, fine, we go to the slow database. But, and this is the key part, on the way back, we store that data in the cache. Why? So the next time someone asks for it, it'll be a cache hit.
Okay, great. So caching makes our application fast for one user. But what happens when thousands of users show up at the same time? For that, we need a totally different tool. We don't need an accelerator, we need a multiplier. This is where threads come into the picture.
Imagine a really busy coffee shop with just one cashier. The line would get crazy long, super fast. While threads are like opening up more cash registers. Each thread is like its own little worker that can handle a customer or a user request, all on its own at the same time as the others. This is what we call concurrency, doing many things in parallel.
So, let's recap. We've got our accelerator, caching, to make things fast. And we've got our multiplier, threads, to handle lots of people. The obvious next step is just add more of everything, right? More cache, more threads equals more performance. But this is exactly where things get dangerous. This is where we run headfirst into a hidden trap.
I mean, it seems totally logical, doesn't it? If 10 cashiers are good, then 100 must be 10 times better. Let's just keep adding more and more threads to handle all the traffic.
Wrong. No. And this is without a doubt one of the most common and most costly mistakes in all of system design. Believing this is how you take a perfectly good system and accidentally drive it right off a performance cliff.
And that cliff has a name. It's called thrashing. It's this bizarre, terrifying state where your server looks like it's working harder than ever. The CPU is at 100%, everything is lit up, but it's actually getting almost nothing done. It's spending all of its energy just trying to manage the chaos of all the threads it's juggling without actually finishing any of their work. This chart tells the whole story. As we add more threads, our throughput, the amount of actual work getting done, it goes up. Great, we hit this perfect sweet spot, this optimal point, where the system is just flying. But then, look what happens. As we keep adding more threads past that point, performance doesn't just flatten out, it collapses. It falls off a cliff. That right there is thrashing.
And the symptoms are just brutal. Your CPU is pegged at 100%, but your users are getting timeouts. Latency goes through the roof. The system is working harder than it ever has, but its actual output, the work it's accomplishing, drops to almost nothing. It's the ultimate nightmare of inefficiency.
So how in the world do we fix this? How do we tame this beast? Well, the answer isn't about adding more power. It's not about brute force. The answer is control. It's about being smarter with the resources we already have.
And this right here is our best weapon against thrashing. Instead of letting our system create a new thread for every single request, which leads to total chaos, we create what's called a bounded or fixed-sized thread pool. We're basically telling the system, hey, you get 200 workers. That's it. No more. This puts a hard limit on the chaos and gives us predictable, stable performance.
So really, the playbook for avoiding this mess comes down to a few key rules. Number 1, use that fixed-size thread pool. Control your concurrency. Number 2, make sure your cache is big enough to be useful. And number 3, you have to monitor your system, always. You've got to watch your resource usage so you can see problems coming before they take you down.
And look, this isn't just some academic exercise. This exact balancing act is something that every major online platform you use, from your favorite shopping site to your streaming service, has to deal with every second of every single day.
Take a look. An e-commerce site, they use bounded thread pools to handle all the checkout requests while caching the product catalog so the pages load instantly. A search engine, they're caching the most popular search queries like crazy so they don't have to search their entire index every time. And a streaming service. They use advanced stuff like back pressure to stop the system from getting overloaded, which is why your movie keeps playing smoothly. It's all the same principle, finding that perfect balance.
If you take only one thing away from our time together today, please let it be this. Building strong, scalable systems is not about brute force. It's a game of finesse. It's about finding that perfect equilibrium between all your different resources to create performance that is predictable and stable, even under incredible pressure.
And that brings me to a final question for you. Think about a system you work on, or even just one you use every day. Ask yourself, does it have these kinds of controls in place? Or could it thrash if it got hit with a huge amount of traffic? Because knowing the answer to that question, well, that's the difference between a system that's built to last and one that's just waiting to fall apart.